Next, we will see what will happen when we run Java command. What will happen when we run Java command? So, what happens when we run Java command? When we run Java command, JVM is created as a process in our operating system by occupying some memory from our RAM. For executing the given class, JVM performs internally three phases. What are those three phases? We will see now. First, I will make a note about this. When we run Java command, JVM is created as a process in operating system by occupying some memory from our RAM. For executing the given class, JVM performs internally three phases. What are the three phases? We will see now. Whenever we run Java command, how we will run Java command? Like Java example. This is how we will execute our class in our JVM. Whenever you type this command, what is happening internally, we will see now. For example, this is my operating system. This is my OS. Inside OS, a process is created by occupying some memory in RAM. This is my process, which is JVM. JVM is a process which is created by occupying some memory from RAM. Inside OS, it has taken some memory and it has created some runtime environment for us by creating process, because Java virtual machine is a process virtual machine. JVM process. This is my JVM process. Now we will see how my class will be executed. So first we have to compile, right, by using javac example.java. Whenever you compile your file, you will get dot class file. The dot class file will be stored in your hard disk. This is my example.java. Example.class. This is my dot class file which is generated after compiling my example class. And it is stored in my hard disk. This is my example.class which is stored in my hard disk. Next, my JVM process internally we have three phases. Just now we have discussed that. The three phases are loading, class loading, and bytecode verification and interpretation phase. All these three process we will see now. First we have loading phase. Class loading phase. Next we have verification phase. Verify. Next we have interpretation phase. Interpret. I'm using shortcut words because in this diagram I cannot write full word, but all these phases are, first one is class loading phase, and the next verify I have written. Verify is bytecode verification phase, and this interpret is interpretation phase, or we can call it as execution phase. These are the three phases we have in our JVM process. We will see one by one how our execution takes place. So I will write clearly here, so you will not get any confusions. This is class loader. This is bytecode verifier. Next, interpreter. Interpreter is nothing but Git compiler. So these are the three phases we have in our JVM process. So we will see when we execute Java command, Java example, what will happen? JVM is created as a process inside our operating system by occupying some memory from RAM for executing the given class. So first step will start from my hard disk. Dot class file will be loaded. To my JVM. To my JVM load phase. This is my first step. After loading class into JVM process, what will happen? It will verify. Loading phase is completed. Class is loaded into JVM process. Then after loading process, it will verify our class. This is second step. Next, after verifying, what it will do? It will interpret. In the interpretation phase, loaded bytecode will be executed. Whatever the loaded bytecode. In verify phase, after verifying, it will generate bytecode. That bytecode will be executed and displayed as output in this interpret phase. Interpret. This is third phase. After interpreting, how it will execute? By converting our code into that machine language understandable code. After interpreting, it will convert our code into machine language understandable code. If you are using Windows operating system, it will convert into machine language. This bytecode will be converted into that Windows understandable machine language. If you are using Linux operating system, it will convert our bytecode into machine language Linux operating system machine language understandable code. Next, after interpretation and after generating machine language understandable code, what will happen? Our dot class file will be loaded from JVM process to OS. This is my fourth step. Then this dot class file will be loaded in my command prompt. This is my fifth step. Then output will be printed on my console. This is what happens when our class is loaded into JVM in our computer. This is how our class executes inside computer. So we have seen internals, From very scratch level I am explaining. If you have any doubts, you can ask me. Feel free to ask any doubts. I am ready to explain to you by creating some more lectures. Now we will see some descriptions about class loading phase and bytecode verification phase and interpretation phase. We will discuss about all these three processes briefly. What it is doing, how it is doing, we will discuss briefly. First, we will discuss about class loading phase. Class loading phase. So, what is happening in our class loading phase? In class loading phase, class loader will load the given class bytecode into JVM. Once JVM process is created, JVM will search the given class bytecode in its memory. If the given class is not loaded into JVM, JVM will request the class loader. JVM will request the class loader to load the given class bytecode. Then the class loader will load the given class bytecode from the hard disk folder. Whatever we have seen here, everything I am explaining to you. The class loader will load the given class bytecode from the hard disk folder which is configured in my class path environment variable. Now you have clearly understood why we have given class path in our environment variable. To load our class from hard disk, we have configured in class path environment variable. For this reason, we have given class path in our environment variable. If the given class, if the given dot class file is not found, then class loader will throw exception. Has some java.lang.class not found exception, you will get the exception, or it will show could not find or load main class. You will get some type of exceptions. I will make a note about this. In class loading, in class loading phase, class loader will load given class bytecode in JVM. Once JVM process is created, JVM will search the given class bytecode in its memory. If the given class is not loaded into JVM, JVM will request class loader to load the given class bytecode. Then class loader will load the given class bytecode from the hard disk folder, which is configured in class path environment variable. This is what we have discussed just now, and we have one more point to discuss. If the given class file is not found, class loader will throw exception. This is about class loading phase. Next, we will discuss about bytecode verification phase. Bytecode verification phase. So, what is happening in bytecode verification phase? We will discuss now. In bytecode verification phase, the loaded class bytecode will be verified in the bytecode verification phase. After class loading phase is completed, bytecode verifier will verify the loaded bytecode's internal format. If the bytecode is in JVM understandable format, it allows our interpreter to execute the loaded bytecode. If loaded bytecode is not in the JVM understandable format, it will terminate the execution process by throwing exception. This is about bytecode verification process. We will make a note about this. In bytecode verification phase, loaded bytecode will be verified. Next, after class loading phase, bytecode verifier verifies the loaded bytecode's internal format. If the bytecode is in JVM understandable format, then it allows interpreter to execute loaded bytecode as output. If loaded bytecode is not in the JVM understandable format, it will terminate execution process by throwing exception. This is about bytecode verification phase. Next, we will discuss about execution or interpretation phase. Third phase, execution or interpretation phase. So, what is happening in execution and interpretation phase? We will see now. In the interpretation phase, the loaded bytecode will be executed and displays that output in my console. After bytecode verification completed, this interpreter will execute loaded bytecode by converting them into that current operating system machine language. Either it is Windows or Linux or any OS, it will convert, our bytecode will be converted into that current OS machine language. Then while executing bytecode, if any logical mistakes found, then JVM will throw that associated exception. This is how interpretation phase will be done inside JVM process. We will make a note about this. In the interpretation phase, loaded bytecode will be executed and displays output. Next, after bytecode verification completed, interpreter will execute loaded bytecode by converting them into current operating system machine language. While executing bytecode, if any logical mistakes found, then it will throw error. This is about interpretation phase. What is happening inside interpretation phase? These are the three phases inside JVM process. Next we will see the architecture of our JVM. So JVM architecture. So how JVM architecture will look like? So when we run Java command for executing an application, one instance of JVM will start. When we run Java command for executing an application, one instance of JVM will start. Whenever you open command prompt and you type Java example, Java sample, one instance of JVM will start. Then whenever it has started one instance of JVM, inside OS it will occupy some memory from RAM, and it will create a process. That process is called a Java virtual machine process. In that process, it will load and execute our class. Before we have seen all these points, one instance will start by occupying some memory from RAM. So we will see architecture, how it looks like. So this is my class loader subsystem. Class loader subsystem. And this is my runtime area. This is my runtime data area where our Java class is executed. So in runtime area inside JVM, we have some components, JVM components. In the initial lectures, we have discussed human body and JVM body. Human body contains some components to digest and to get energy, and JVM has some components to execute code and to generate output. So we will see what are those components. We have five components. These are five components inside JVM runtime area. What are those five components we have? First we have method area. This is my method area. Next we have heap. I will explain you one by one briefly what these components will do in our JVM. Just note down what are the names of these components. After that we will see briefly what are these. Next we have Java stacks area. Next we have PC registers. All these are runtime areas in our inside JVM. And we have native method stacks. This is my native method stacks runtime environment. And next we have execution engine in our JVM. This is my execution engine. This is how our JVM architecture will look like. So class loader subsystem we have discussed. What this class loader subsystem will do? It will load our class into our runtime area. Class loader will be having class files. Class files will be having inside class loader subsystem. Whenever we execute Java command, our class loader subsystem will search for our .class file inside hard disk. Then after searching .class file, if it got that .class file, then it will load the .class file into this class loader subsystem. After loading the .class file into this class loader subsystem, then it will send that .class file to our Java runtime environment, JVM runtime environment. After sending the .class file into runtime environment, first whenever you have given Java command, Java some example or Java some sample, then JVM process will start. After JVM process starts, then control comes to our method area of runtime. Then it will search for that dot class file. Then it will search for the dot class file. Then it is not. Then if it did not find the dot class file in method area, this method area will request our class loader subsystem to load the dot class file into this runtime area. Then what this class loader subsystem will do? This class loader subsystem will search for our dot class file in our hard disk by using environment variables class path. In that class path, whatever the folder we have given, it will search in that hard disk. If it find the dot class file, then it will store in class loader subsystem. From this, it will send the dot class file into this runtime area. Then the dot class file will be loaded into method area. Then whatever the process takes place inside runtime area will take place. We will see one example. We will create a class and we will see how the class variables and methods will be loaded. That I will explain in next lectures. Now I am showing just the architecture and what are runtime areas we have. I have just shown you. Next, in next lecture we will see briefly about this method area, heap area, Java stacks, PC registers and native method stacks. What all these runtime areas will do, I will explain you briefly. Next, we have execution engine. What this execution engine will do? After loading class into method area, after assigning variables after execution completed, then output will be forwarded to our console from execution engine. So this is how our JVM architecture looks like. We will see one by one about JVM components. Our class loader subsystem and our runtime data areas and our execution engine and Java native interface. We will see about all these components briefly. What this runtime data areas will do in our JVM. These runtime data areas are responsible to provide memory to store bytecode, objects, parameters, local variables, return values and intermediate results of computations. All this will be stored inside runtime data areas. We will see briefly with example in our next lectures. Just note down which component will do what operations. And class loader subsystem. What class loader subsystem will do? It is responsible to load and store given class bytecode into JVM from both the program and the Java API. And also it is responsible to link the loaded class to our runtime data areas and initialize the loaded class memory. Next we have execution engine. We have discussed execution engine is responsible to execute the loaded bytecode with the help of interpreter and Git compiler and to show output in our console. And we have JNI. JNI is nothing but Java native interface, or we can call native method interface. What this native method interface will do in our JVM? It is responsible to link Java method to native method, executes native method from a Java program and returns its result to Java program. Native methods are nothing but it has written in other programming languages. Like for example, we are using Windows operating system. Some code we have written in C language, and this Java native interface is responsible to link Java method to native method. It executes that native method from Java program, whatever the native method we have written, which is in another language, and it executes that native method from Java program and returns its result to our Java program. This is the use of JNI. It is responsible to link Java method to native method. It executes native method from a Java program. Native method is nothing but which we have written in another programming language, C language for example. Then the C language program executes, it will be executed by Java native interface, and it executes the native method from a Java program and returns its result to our Java program. So this is how JVM architecture looks like. I will make a note about all these runtime areas and class loader subsystem, so you will get full clarity about our architecture. First, I will explain about JVM components. JVM components. We have discussed about all those JVM components, whatever we have in our JVM. JVM is a combination of 4 components. What are those 4 components? Class loader subsystem. And runtime data areas. And execution engine. And Java native interface, JNI. These are the 4 components inside JVM. Class loader subsystem. This is class loader subsystem. Runtime data areas. All this comes under runtime data areas. And we have execution engine. And we have Java native interface. This is our native method interface or Java method interface. Both are same. Now we will see about all these components briefly in depth. So first we will discuss about class loader subsystem. So we have discussed class loader subsystem is responsible to load and store given class. Class loader subsystem is responsible to load and store given class bytecode into JVM from both the program and the Java API. Predefined classes and our user defined classes, which is developed by ourselves. Predefined classes is nothing but which is developed by Java community. All those classes will be loaded into class loader subsystem, and also it is responsible to link the loaded class to runtime application of JVM. It is responsible to link that class to this runtime data areas and initialize the loaded class memory. We will make a note about that. It is responsible to load and store given class bytecode into JVM from both the program and the Java API, and also it is responsible to link the loaded class to runtime application of JVM and initialize the loaded class memory. So this is about class loader subsystem. Next we will discuss about runtime data areas. Runtime data areas. Runtime data areas. So what runtime areas is doing in JVM, we will see now. Runtime data area components. All these components, method area, heap area, Java stacks area, PC registers and native method stacks, all these are responsible to provide memory to store bytecode and to store objects and to store parameters and local variables and return values and intermediate results of computations. All this data it should store inside memory. It is responsible to provide memory for all those systems, all those variables, bytecode, objects, parameter. It have to provide memory for all those systems. We will make a note about this. It is responsible to provide memory to store bytecode, objects, parameters, local variables, or return values, and intermediate results of computations. This is about runtime data areas. Next we have execution engine. Execution engine. What this execution engine is doing inside JVM? This execution engine is responsible to execute the loaded class bytecode with the help of interpreter and Git compiler and to show the output in our console. This execution engine is responsible to execute loaded bytecode with the help of interpreter. Interpreter is nothing but a Git compiler, just-in-time compiler. Then it will show the output in our console. We will make a note about this. It is responsible to execute the loaded bytecode with the help of interpreter and Git compiler. And next we have Java Native Interface, JNI. What this native method interface or Java Native Interface is doing in our JVM, we will see. This Java Native Interface or native method interface, it is responsible to link Java method to native method. What it is doing is it executes native method. Native method is a program code which we have written in other language like C language. For example, I have written some code in C language in our Java class. Then this native method interface will execute that native method from a Java program and it returns its result to our Java program. This is the operations done by native method interface or Java native interface. We will make a note about that. Java native interface. It is responsible to link Java method to native method. It executes native method from a Java program and returns its result to Java program. This is about Java native interface.